5 volts. So what was the cutoff point here? 10. What was my saturation for the current? Was it 22 or 2.2?
Oh, 2.2, sorry.
2.2 milliamps. And it just so happened, when through my calculations, that it was right at the midpoint. Okay? It happened to be 1.1 milliamps. This was not planned at all. It just worked out that way. Okay? I calculated VB, I calculated VE, I calculated VC, and then I calculated VCE. It worked out to 5 volts. I calculated IC here, and it worked out to 1.1 milliamp. Now, let's calculate IB on page 4. The last calculation we still haven't completed, right? On page 4. Do you have the calculation for IB? Did we do it last class? Okay. So, yeah, okay. So let's do the calculation for IB on page 4, and let's do it using this equation here. IB is equal to VB over R in base. Okay, so let's find R in base first. R in base. The resistance at the base. This is something that you cannot measure. It's something that you feel in the circuit. Okay? And that's what these double arrows mean. It's the resistance we feel. And it's beta times bigger, beta times IE, no, VB over IE. So, how much was beta? Is it 100 or 150? 150. VB, I calculated, top of page 4. 2.07. IE, I calculated, third one down. 1.14. So let's find out how much this is. $282 kilo ohms. Okay. Anybody disagree? Okay. So let's now find IB. Let's take this value, plug it in this equation. VB is 2.07 divided by 282K. This 282K is the resistance that I feel right here. Okay? R in base. How much? Should be in microamps, isn't it? 7.34 microamps. Okay. So that's our IB. So that's our example on page 3, a voltage divider circuit. And it so happens that its Q point is in the middle. The next topic is, what if my circuit is not stiff? Remember we said that this, with a voltage divider circuit, the circuit is classified as stiff if the load happens to be 10 times bigger than R2, okay? And if this resistance, if the transistor that acts like a load is beta times RE is 10 times bigger than R2, then the circuit is classified as stiff. And if it is stiff, the calculation and the design of the circuit is simpler, and the equations of page 2 hold for a stiff circuit. That's why at the top of page 2 it says stiff voltage divider circuit. On page 5 we have notes that says, what if the circuit is not stiff? What if my beta times RE is less than, what if this R in base, beta times RE is less than 10 times R2? If that's the case, we have to do a fairly complicated calculation, and it involves a thing called a Thevenin's theorem. We're not going to cover this in our class. I'm providing you with the notes, and there's an example on the next page, which is for a not stiff circuit, okay? But because of time constraints, I'm providing you with the information. In the event that the circuit is not stiff, you just follow the two equations to find IC and VCE on page 5 and come up with your load line and your Q point, okay, if the circuit is not stiff. Page 8. Go to page 8 now. PNP voltage divider circuit. What is a PNP voltage divider circuit? It's just like an NPN, except for what? VCC is negative. So in a PNP circuit, the analysis is the same as NPN. The only thing is VCC is negative, so we do all the calculations as if it was an NPN circuit, but after the dotted line on page 8 and 9, what do? Change the polarity of my answer from positive voltage to negative voltage, from positive current to negative current, okay? We've done that before, and so we're going to go past that. You can fill out the information on pages 8 and 9, and if you have any questions, you can ask me. Otherwise, you do the same analysis as we did in the example on page 3 and 4. What I want to go to today is designing a circuit, a voltage divider circuit.